And welcome everybody once again to the Daily Space Weather. I'm your host Dan, aka smAsho, starting things out today looking at the local yellow dwarf. Thanks for tuning in, stargazers. We're looking at it in 3 different emission spectral states of iron. So 335, 193, and 94 angstroms are all different UV emission spectral states of very, very hot iron. Iron which wants more electrons. And that's what gives you that distinctive purple look there. Some interesting stuff to cover, including coronal mass ejection, Sagittarius A star, and more. We're going to even look at some financial stuff. For once, the Smash Light segment will be integrated. The 10.7 centimeter radio flux still at 82 solar flux units. There is the 1-year chart of that, courtesy solon.info. And for you new viewers out there, the 10.7 centimeter radio flux is the radio output of the outer solar corona, which is directly proportional to sunspot number, as you can see on the 2 charts before you. Here's the sun in 304 angstroms, and we saw coronal mass ejection. We'll show you all about the telemetry of it momentarily. And it happened right at the beginning of this video here, around 8 o'clock Universal Time yesterday on the 17th. And it came out of the southern portion of the sun. I believe it's this filament right here. And we'll show you why momentarily. So we've got some great helio viewer movies today. Sunspot 2793 has degraded a bit. It may lose its umbra today, as its umbra are starting to look a little bit fuzzy. Before we do any of that, let's take a look at the view from stereo A, as that was where I noticed the coronal mass ejection from. So if you look around here, you can see sort of a halo over the top of the sun there. And stereo A is located at Lagrange point 5. So here's a diagram showing you where stereo A is located with respect to the Earth. And you can also see Venus swinging around the back of stereo A's coronagraph, and you can see the disappearance of this plasma filament out here in the Earth-facing zone. Guess what? It wasn't an Earth-facing coronal mass ejection. So here's the view from going to Lagrange point 1, in between the Earth and the Sun. Here's the LASCO C2. And you can see a great view of that, as well as Mercury, which is at the bottom of the screen there. And that coronal mass ejection looks like it will entirely miss the Earth to the west. Great view of that, though. The bubble-like structure as it propagates out of the corona. And let's look at it from the LASCO C3 as well. There's the view from LASCO C3. And we do see a tiny bit of ejecta out of the eastern portion also. I wouldn't expect this to trigger anything particularly measurable, if measurable at all, from the Earth's perspective. And let's move on. That was actually yesterday's video. Next, I'd like to thank our patrons, the true source of funding for the content. Please consider becoming a patron if you enjoy the videos. Help to keep us in existence, help to keep the videos free and publicly visible. We recommend joining at the $3 or more a month level, as we're eliminating $1 and $2 tiers at the end of the year. Please upgrade if you're a $1 patron to a $3 per month level. And if not, we still greatly appreciate whatever you'd like to do. So in any case, patreon.com/smAshomash. And we send all kinds of extra stuff. Although we've been a little bit inactive this month. And that, patrons, is indeed because we've been too busy. So we've got some Helio Viewer movies we're going to show you here. Just bear with me one moment. We are streaming live. And I'll bring some of those up for you in just a second here. And I regret that we haven't put up any images of our snowstorm. I was just too busy yesterday, and maybe I'll put some up today. We got about almost exactly what I forecasted, somewhere around maybe 10 inches, something like that. And here we've got some Helio Viewer movies for you. First, we're going to look at the 171 angstroms. What the heck? All right. Here's 171 angstroms. And almost all of the activity is in the south. We do have a significant coronal hole in the north. Here's 94 angstroms. And let's move on to the Smash Light segment. We'll be talking a little bit about financial stuff. I apologize for the delay. And the first thing I'd like to note is that we will be streaming live on the solstice. So what will you be doing at 5:02 and 20 seconds Eastern Standard Time on December 21st? We'll be streaming live at youtube.com/smAsho, doing a live stream daily space weather solstice exclusive. So make sure you join us for that. There's the countdown to the solstice. What will you be doing with your last 3 days of autumn? Or if you're in the southern hemisphere, your last 3 days of spring? Any exciting winter or summer plans? We wish you a happy solstice. By the way, thanks to all of our new viewers and everybody viewing the videos over on YouTube, youtube.com/smAsho. Please press like and subscribe if you enjoy the content. And please don't forget to share with your friends and foes, your science noobs, and your science pros on social media. We're also all over social media. We're on Twitter, so follow us there if you have a Twitter account. You may enjoy the content there. Thanks to our new followers over on Twitter. And we're also on Instagram, and I just wanted to talk about the COVID for a quick moment. Yeah, COVID. You're still hanging over my head like the sword of Damocles. It's enough to make me want to put on some safety glasses, because I heard, oh, nose, you could infect me through my eyes. Oh, nose, I'm so scared. So let's put up this graph here, which I've posted on our Instagram. Mask up and lock down, COVIDiots, whether it's effective or whether it's totally irrelevant, right? Are you compliant with whatever mandates are made by bureaucrats? Then mask up, bruh. Related, you look like a dick in that mask, and you aren't saving anybody. Asymptomatic people aren't transmitting coronavirus, and quarantining healthy people is also ineffective at containing a virus. If you're sick, stay at home. Same rules as always. Merry beeping Christmas. And we wish you a propaganda-free Christmas over here on our Instagram page. COVID. I'm going to pop you like a cheap Chinese plastic bubble. See that? So yeah, just to reiterate, we're all over social media, and you can link to all of our social media accounts if you head to smashomash.com. So go over and check our links out there at smashomash.com. You look at this little arrow in the upper right, just press that, it'll pop a drawer out, it'll show you the VoIP line and the email address and all the other social media links, as well as the Smash store and the smAsho store. Today's featured product is the Are You Safe Yet Neck Gaiter. Yes. Are you safe yet? Would you like to go out in public and ask a whole lot of COVIDiots if they're safe yet? Well, do so with our neck gaiter, or perhaps our Are You Safe Yet ear loop mask. Don't forget to enter the promo code SMASHO through Christmas to save 10% on checkout for all orders on either Teespring store the smAsho store or the Smash store. Also, check out the forum if you like. Let's talk about some financial stuff. All of this data provided courtesy of CNBC.com, the non-official news source of the Smash News Network. So check out the Bitcoin chart. There's the one-year chart of Bitcoin now at $23,000 per coin. While this isn't official investment advice, I would say don't go chasing tigers. What you want to do is buy low and sell high. I know it sounds like a complex thing. Here's the one-year chart of Ethereum, looking a little bit less extreme and overinflated. And here's a one-year chart of the dollar index. Yes, as Peter Schiff reported on Twitter last night, the U.S. dollar index has closed, well, it closed yesterday below 90.90. So that's not exactly what you want to see. If you're holding dollars, obviously, you don't want to see a devaluation of those dollars. And by the way, this is an indication that people are expecting inflation of the U.S. dollar. And by the way, if you're wondering what inflation is, it's not the raising of prices. Inflation is you being able to buy less stuff with your dollars. It's a devaluation of the currency because of money printing. That's the main cause of inflation, in case you were wondering. Here's a one-year chart of gold, which is not looking as overinflated as Bitcoin. So there's that. And this is the main hedge against inflation, historically speaking. And just for a little history lesson, 1 ounce of gold still buys you about the same amount of stuff as it did in Greek times. Back then it bought you a nice toga and a nice pair of sandals. Now it'll still buy you a nice suit and a nice outfit for about $1,800. And here's the chart of silver. This is kind of the Ethereum of precious metals. And leave us a comment if you remember when we were reporting on silver at below $12 per ounce. And if you bought some, maybe consider becoming a patron. And especially if you purchase silver based on our advice. By the way, we're also on BitChute. Again, check smAshomash.com for all the social media links. We are streaming live today at twitch.tv/smAshomash. Thanks for everybody tuning in over there. We've got a new follower over at Twitch. Cheers to you, our newest Twitch follower. Let me just check the live stream here. Thanks for leaving a comment. Raycar1748. Good morning. Yeah! Who remembers the Howard Dean scream? And then we're going to Pennsylvania, and North Carolina, and New Mexico, and South Dakota, and then we're going to Washington, D.C., take the White House. That was quite a moment. I was planning on voting for Howard Dean that year, by the way. And here ends today's Smash Lights. And we're going to talk cosmology for a quick moment. We're not going to roll dice. We're going to talk about the massive radio source, the most massive radio source in the Milky Way galaxy. Here it is on the 2MASS, which is infrared spectrum. It's Sagittarius A star. And thanks again to that commenter who left us a comment about Sagittarius A star being a, quote, supermassive black hole, end quote. I don't refer to it as a supermassive black hole or anything as black holes. I refer to these objects as radio sources or X-ray sources if relevant. Now we're looking at it on the Chandra X-ray telescope, and if you're wondering what these are, that's S1 and S2, the two most massive blue supergiants orbiting this apparent gravitational field source as well. Sagittarius A star, the core of the Milky Way galaxy. And I'll zoom back out using the 2MASS. Actually, let's use the iris. Okay, the iris is a little bit too bright there. So there's the 2MASS, the infrared spectrum. Let me recenter that. There we go. And yes, Sagittarius A star, the core of the Milky Way galaxy. I don't know what I've clicked there. Come on now. There we go. And there's a zoom out of the Milky Way galactic disk. Milky Way galaxy team for the win. Here are the X-ray transients from Sagittarius A star. And you can see here it's been very quiet in X-ray over the past 2 weeks. Here's the historic chart of Sagittarius A's X-ray emissions. And you can follow these yourself if you want to monitor the core of the Milky Way galaxy at the Neil Gorell Swift Observatory. Lastly, I'd like to talk about the sun. So these videos, these daily space weather videos, are indeed cosmology segments. Why? Because the sun is the Rosetta Stone of all cosmology. For example, if we figure out that the sun behaves the way it does, based on some new information, it may rewrite all of cosmology, a thing that's actually happening. And that's the end of today's cosmology segment. Let's move on to some more data, such as the real-time solar wind, which we had some trouble loading. We did see an increase in the solar wind density. Let's see if this data's functioning. And there we go. So we saw an uptick here in the solar wind density. It looks like a small coronal mass ejection strike, as we see an uptick in the speed and the density at the same time, right there. An indication of a coronal mass ejection strike. It's pretty minor, as neither the speed or density jumped up too much. So that's something to keep an eye on there throughout the day, the real-time solar wind having just increased. And the solar wind speed was all the way as low as around 250 kilometers per second yesterday at its low. One of the lowest solar wind speeds we've ever reported on the daily space weather videos. Current solar wind speed up to about 292 kilometers per second. Current solar wind density 14.2 protons per cubic centimeter. Geez. What is up with that? There's the KP index, a measurement of global geomagnetism, currently at 1, having been only at 1 or 0 for the past 3 days. And here's a visualization of the incoming proton strike. You'll see an uptick in the solar wind pressure here toward the end of the video. It's 4 hours of data, and that pressure increase will have come about 2 hours ago, I think. We'll let that play through there as it refreshed in the middle of the video. One of the dangers of streaming live. And here's one of the me vanishing while streaming live. And here comes that pressure increase caused by the increased density and increased speed of the solar wind. Pretty minor there. A little bit of ejecta, likely coming directly from the local yellow dwarf. And by the way, if you're wondering what the solar wind is made of, it's mostly made of hydrogen nuclei. But there are also all kinds of other heavier elements in there, as well as electrons. Helium nuclei are also pretty common in the solar wind. Here's 4 hours of data of ground magnetic perturbations, and indeed you can see some induction caused. We'll let that play through a second time there. This is measuring changes in the Earth's B field. So the B field is the field going through the magnet, this particular magnet being the Earth. And there you can see some magnetic perturbations over the North Poles and the South Pole. And yes, there are 2 North Poles, if you're wondering. Proton flux remains flatlined here over the past 3 days. No real surprises there. And we don't see any solar flaring happening as that sunspot 2793 degrades. Here's a star chart. Know the difference between your hole and Uranus. I mean, between Uranus and a hole in the ground by using in-the-sky.org. And maybe you'll get very scared and spooked when Uranus ends up in Taurus. You'll be very scared and spooked. Perhaps you'll head to a Bohemian Grove ceremony and sacrifice some babies. We hope not. Next, looking at a solar system chart here. I like to use theplanetstoday.com. It's a good visualization for our viewers. And look, folks, we've got a straight line here in the solar system. A line between the Earth, Mars, and Uranus. Again, know the difference between Uranus and a hole in the ground. And be very scared and spooked. This means that Uranus and Mars are going to go to war and something or other. And don't join the Church of Moloch. Here's where things will be in a week. Assuming that the scary, spooky galactic current sheet doesn't swallow up Neptune and change its rotation to backwards. Or some other nonsense. Here's the GOES magnetometer. That's a 3-day chart, measured by the GOES 16, which does so at the F ionosphere layer. By the way, the ionosphere doesn't typically have an F2 layer at nighttime. It degrades to an F layer. There's a little tidbit for you. Magnetometer looking pretty smooth here. And the Earth is solidly in the North Pole-oriented current sheet. Now we're looking at an aspect of the National Sunspot Observatory. It's what I like to call the Gong 2 data. And it's a very important aspect of solar forecasting. We can see some activity on the far side of the sun based on the way those field force lines look. And this is stereo A at Lagrange point 5, and that's stereo B at Lagrange point 4. And this data uses their magnetometers as well as 51 ground-based magnetometers. North Pole current sheet for the win. And here's a different view of the same data. It's the line-of-sight coronal hole field plot. And you can see that North Pole-oriented coronal hole moving into the Earth-facing zone there is quite significant, and it's extending nearly all the way down to the equator. Here's another view of essentially the same stuff, but this also includes the solar magnetogram and the poloidal fields. Next, we'll look at the sun's atmosphere, the solar corona magnetic field plot, the chaotic environment of the sun's atmosphere, there shown in magnetic field force lines, closed potential field surface source lines in pink, and open ones in purple or black. Those are coronal hole potential field surface source lines. Next, we'll talk electrons. We don't see so many. We don't see any charging hazards. There's a 1-year chart of the electron flux. And we're expecting a further downtick here. And I would tend to agree with that forecast from NOAA. Downtick forecasted for the electron flux. And you can see the electron flux is quite cratered here, although not nearly as low as we saw it around solar minimum, when it would be cratered for days and days during coronal hole wind streams. Next, looking at a visualization of the air column here. It's the total electron content forecast. This will give you an idea of your GPS errors. And at these low levels of electron flux, we typically see more anomalous portions of electron blobs over the planet. I'll let it play through a second time. And we've been seeing regular anomalies here over the northern portion of the North American continent at nighttime. Typically, we see more GPS errors around the equator at noon. And here's just a diagram of things like the Van Allen belts and the altitudes of the SDO and so on. By the way, the SDO performs a figure-8 style orbit around the equator. That's how it's able to maintain its constant view of the sun, except for when the moon eclipses it. And here's a diagram of the atmosphere, and you can see where the F layer is. It's between 300 and 400 kilometers of altitude. That portion of the ionosphere is what we'll show you next. And this chart also shows you the penetration of different bands of the electromagnetic spectrum, from X-rays down to visible and infrared light. Here's a visualization of the ionosphere, and it's looking anomalous once again in the southern hemisphere. Pretty heavily charged up, a typical thing we see when we see low levels of electron flux. If you're wondering what I'm drinking, it's Andes Gold Peruvian organic coffee, along with cocoa and cayenne pepper, yes. Anyway, here's the latest image of the ionosphere coming in at 9:45 Universal Time. And you can see once again, quite charged here in the southern hemisphere. And it's almost summer in the southern hemisphere. Next, we'll look at volcanoes, as I'm always wondering what's going on with that. It's part of the daily space weather videos. All your weather comes from space. And Some of your weather may come from volcanoes. For instance, if you're downstream from one, Karimsky's exploding on the Kamchatka Peninsula, and it's producing a 9,000-foot plume of ash. Abiko, 10,000-foot plume of ash above it. Sakurajima, not identifiable in satellite imagery. It's probably cloudy. It could be erupting. Please don't build a campsite on the lower slopes. It could kill you. Dakono's exploding also, flight level 070. It's a 7,000-foot ash plume. Sporadic emissions from both Popocatépetl and Fuego as they mildly explode. I don't know what's mild about an explosive activity from a volcano, but maybe not as serious of eruptions as we've seen. Sangay exploding as well, 21,000-foot ash plume there. Revenador exploding, 15,000-foot ash plume there. And unable to detect both Sabancaya and Villarica. I would remind our viewers to not attempt to pole vault or tightrope walk the caldera, as that could be unhealthful as well. No other health advice in today's daily space weather video. Don't vacation on the sun. Okay, I lied. And let's look at earthquakes. Nothing over a 6 magnitude. In fact, another lull in earthquakes here. Here's a very shallow quake happening at 1,600 meters above sea level. That one underneath Mauna Loa. There's the location of that. And let's get back to the list. There's a small deep quake in Alaska. There was one yesterday. I didn't even mention it because it's a very small magnitude. Here's a deep quake at Guam. Please leave us a comment if you felt that quake, perhaps on a U.S. military base. It's a 4.9 magnitude at 118 kilometers depth. Here's a deep quake in Mexico. It's a 4.6 magnitude at 110 kilometers. Followed by a deep quake in Argentina. And then one in Afghanistan. That one less than an hour later. A 4.1 magnitude at nearly 200 kilometers depth. So it's a lull in earthquake, folks. And earthquake droughts always end in earthquakes if you're in an earthquake-prone zone, such as these areas. Please be an asset, not a liability, as the 7, 8, and 9 magnitude quakes have been shockingly infrequent. A massive drought of large quakes over the past, well, 2 years. Next, looking at jet streams, here are the jets of the eastern world, and here's me checking out the stream. And indeed, there was a 5.3 magnitude quake in Veracruz, Mexico, at 92 kilometers depth. And thanks for letting us know, Raycar 1748. Here are the jet streams of the western world, now that we've showed you the eastern world. And check out the extreme meridional jet stream flow over the northern U.S. there. Major kinks in the jet stream, as well as down here, making for some hot weather in southern Mexico. And I'm always interested in where lightning